All right. Well, yeah, thanks again for attending today. Um, let's just dive on in. So we over at Decipher, we identified that there was a bit of a need for SQL upskilling, and we thought, well, let's just put on a series following in the footsteps of Nicole Turvey, who's on our call here today. She's set up a great series on R, and we thought, well, we could do something similar for SQL. And there's no reason this needs to be Decipher only. We may as well open it up because a lot of people use SQL all across CDPHE. And so we came up with this idea for a SQL study hall following in Nicole's footsteps there. And just to give you a sense of what our goals are, as you may expect, our overall goal is just to raise the level of SQL proficiency across CDPHE. A lot of us use SQL either directly or indirectly, but a lot of us maybe don't know everything about it and would love to learn more. And I think there were a lot of people interested, so that kind of proves that out. And to kind of define those a little more concretely, raising SQL proficiency means giving you the skills you need to perform day-to-day tasks using SQL, like writing a query or anything along those lines. We want to make sure you guys have the confidence to use SQL terminology so that when you are blocked on something and you go to Stack Overflow or wherever, you can actually understand the answers instead of just copy pasting something in and then hoping it works, right? And then we're going to record all of these and potentially create a long-term resource for future CDPHE staff who want to learn more about SQL. They can refer to these old lessons and not have to deal with anything else, random things online, that kind of thing. Overall, the focus is on just foundational skills and understanding how SQL works. We will obviously have tons of examples and practice things to work on, but we're not addressing any one technical issue in these sessions. More about giving you the means to address any technical issue that comes up. So I put a beautiful picture of a fisherman here because we are teaching how to fish. But maybe we are all, in a way, more teaching like the conceptual underpinnings of fishing so that you could understand how to fish for all kinds of different fish in the future. Yeah. A bit more about the goal, the way that these will be structured. As I'm sure I've probably said too many times, these are totally informal, 100% optional, just a resource we're creating, and happy to have you be a part of that. So please don't feel like you need to show up every week or anything like that. We will be recording all these sessions and putting the recordings on a centralized document so you can refer to them in the future if you need to. Each session is going to cover a special topic of the day. Today's is just the general overview of the course and some preliminary knowledge. Obviously, we want to make sure that we raise all the boats and not just the ones that are already floating high. So we will start with the basics, kind of what's a query, what's the syntax, and then we'll move on to more complex stuff like optimizing your queries, stored procedures, things like that. So I just say that so that if you feel like, yeah, I kind of know the syntax already, I'm good on that. If you need to skip a session or two, that's all good. At the same time, I've always found it valuable to just hear the basics again. Everyone presents them differently, and sometimes you get a different perspective on them just by hearing it again. Questions are welcome really at any point. Please just raise your hand and interrupt me. If you feel like you don't want to say anything out loud, you can put it in the chat. If you want to say it in an even more quiet way, you can just chat me directly and I'll answer you after the call. I know I was probably one of the annoying people in college or whatever who often asked questions that really just restated what the professors were already saying. But the result was that I more or less always understood it. So please feel free to do the same yourself or ask any question, no matter how dumb. There's like 60 people on the call right now, so I'm sure probably half of them have the same question you do. So there's really... this is meant to benefit you, and if it just goes in one ear out the other, then it didn't really do that. So make sure it works for you. For the next couple of weeks, we'll do a session every week. On the interest form, it was kind of a tie between weekly, bi-weekly. So I thought, let's do every week to catch everyone up, and then we'll go to every other week as we get to more complex subjects, and people are, everyone's busy. So. That said, if there are any topics you're feeling like I'm really excited to manage and work on, please let me know, and I can try to prioritize those. And honestly, a lot of the people on this call do have pretty good knowledge of SQL already. So if down the road you want to teach a class yourself, you're more than welcome to do that. We just coordinate it, and you can take over a presentation. Cool. Any questions so far about the sessions and the goals? Pretty straightforward. Okay, so I wanted to maybe just mention a few words about the relationship to the Lakehouse project. So some of you, I think, may be coming from like the Tableau world, but a lot of you might also be coming from the newly established public health data Lakehouse over at Decipher. And because that system makes heavy use of SQL, you may be feeling like, okay, this is my chance. It's the right time for me to learn SQL. And that's part of why we created this. I myself work on that project, and it was that gap that was the genesis of these sessions. That said, while the study hall is going to use the Lakehouse for the examples, that's going to be our sort of development environment. That's really only because the Lakehouse functions as a 100% CDPHE managed database. We don't need to go through OIT to create tables. We don't need to go through OIT to update tables or create scheduled tasks, that kind of thing in the Lakehouse. So we have a little more freedom to do more complex things and demonstrate more exciting things in SQL if we use the Lakehouse for that. Yeah, so, but that said, no use of the Lakehouse is necessary to benefit from these sessions. You could totally use any OIT managed system, the SQL Server, run your queries on that, and everything we talk about here with some very minor changes to SQL dialect would still apply. And just as a 2-second sales pitch, if you think like, I would like to have access to a CDPHE managed database and not have to go through OIT for things, just send me a chat and we'll sort that out. And on that note, we did want to set up an environment where people who may not have a ton of access to SQL could still practice and make use of it. So we, although I think I have to like double approve it with the governance committee of the Lakehouse, we will probably set up a sort of sandbox area in the Google Cloud environment that we have, so that we can grant anyone who wants access there. You can create tables, run queries, and do whatever without having to worry about impacting anyone else or real environments or anything like that. So yeah, if you need access to that kind of SQL playground, or if you just want to learn more about the Lakehouse, you can just reach out to me on my emails right there. Cool. Like I said, I'll probably keep mention of the Lakehouse to a minimum. You don't need it, but I just wanted to kind of clear the air, make sure it's clear why I will be using it for a lot of some of these examples. All right, so before talking too much about SQL, I just wanted to make sure we kind of have like a baseline knowledge of computer science and how it works, how computers work and all that stuff. I remember when I learned programming back in the day, not that many days ago, but they just kind of told me, write your statement like this, and I was very confused about how any of it actually did anything. And a bit of my background, I'm a philosophy professor, so I need to have everything very structured, and foundational knowledge is very important, right? So yeah, so I thought I'd provide that to you so you can have it from the get-go, and you can kind of understand like what is happening at all those different layers in the tech stack when you run a SQL statement. And that way, when you have to troubleshoot things, you have a little more deeper understanding. Okay, so let's just get into it. A computer, right? You could define a computer any of 100 different ways. The way I kind of want to suggest that we understand them here is that computers are essentially tools for storing and manipulating data, right? The hard drive and other items in your computer typically store data and or manipulate the data, and that's really all it does. There's obviously an input setup with your keyboard and an output setup with your screen, but that is the heart and soul of the computer, is just managing data. How does it do that? Won't bore you with a bunch of details about logic gates or anything, but computers just use electrical charges on all those little wires in there to represent numbers, essentially. You may have heard, what is it? The internet is just a bunch of tubes. Well, your computer is just a bunch of wires, and they're very, very thin and organized in very particular patterns, but they charge electrical charge. They store these electrical charges, and with those on-offs, you can represent numbers. So like they do it in binary, right? So it's like, 1 is 1, and then 0, 1, 0 is 2, and so forth. But then once you have numbers, you can use the numbers to represent anything else, like characters or positions on a screen to color certain pixels so that the UI looks right, and so forth, right? So the important thing to remember there is that essentially the computer is only ever doing math, right? It's just changing the values of numbers in different places according to a prescribed pattern. And the memory of the computer just is this pattern of electrical charges held in the machinery of your device. That some of it's more stable. That's like the hard drive where you keep all your like files, and some of it is more active, and that's like the RAM that manages your application itself. But fundamentally, it is just a set of electrical charges, right? And then when you work with a database, you are just changing those patterns, right? When you run a query against the database, you're saying, please translate that set of patterns into something I can understand in a database format. When you update the database or work with an application, you are just changing that pattern of electrical charges down at the base level. Cool. I'll just pause for questions. Anyone have anything they want to add or wonder about? Cool. So, okay, we talked a bit about how we're storing the data itself. Now let's talk about how you change it. So the data manipulation is done through programs, right? No one shouldn't be particularly new to anyone. A program, just the set of rules, right, for changing those electrical charges according to certain patterns. You're running a program right now as you watch the screen, and programs are sort of stacked on top of one another, and that's why this is a beautiful stack of waffles here. And each layer sort of interacts with the ones above and below it. And that's why, although the computer is fundamentally just storing electrical charges, we almost never give instructions to the computer about electrical charges, right? In fact, there are many, many layers between us and the actual hardware. Those layers of abstraction create what's called the tech stack, so that you can have people who have basically no technical knowledge still interacting with those electrical charges, right? So if you open a application like Google Sheets or Google Docs and you start writing something, there's that user interface layer that is then interacting with the database layer, which is then interacting with the operating system, which is then interacting with the actual electrical charges. So through all those layers, there can be different problems that you need to troubleshoot, different kinds of interaction and rules for how you can do things. And then where you choose to interface with that stack dictates a lot of what can happen, right? So we as programmers are going a little deeper than just that writing a Google Doc layer. Most of us aren't going all the way down to the operating system layer. We're operating somewhere in the middle, where we have to be always aware of what's going on above us and what's going on below us. So when you're dealing with a SQL database, 9 times out of 10, that database is feeding data to an application. So to take a recent example, someone was asking me, oh, I can't find this data on the database. It must be missing. Well, if I look one layer up in the application, I don't see it there. So it's not really missing from the database in any real sense. It's missing from the application too. So there's nothing wrong with the database itself, right? The database is just showing what's in the application, right? And vice versa. And so if there had been a scenario where it's showing in the application but not on the database or vice versa, that would tell us there is a real problem there. Cool. Any questions about how that works? So I way oversimplified it. There's probably like 20 layers, but you get the main idea. Okay, so yeah, so just again, at this, when we operate with SQL, we're operating in the middle, so we always want to be aware of what's going on above and below. Now, the important thing I want to mention about this that kind of comes out as a consequence is if you think of computers as tools for storing and manipulating data, then the corollary is that a computer is conceptually at least distinct from the screen and the keyboard that you use to manage it, right? In everyday language, when people say, I got to go pick up my computer or I went and bought a computer, they're not talking about just the computer. They're talking about the computer plus its screen, plus all the ports and wires, plus the charger, plus the mouse, plus the keyboard, all these other things that allow you to interact with the computer and make it meaningful to you. On its own, a computer is just a box for doing math. If you can't see the answers or give it the questions, you kind of have a useless tool, right? So you have to have a screen to make it useful. You have to have a keyboard to give it inputs, but those are not key parts of the computer itself. And maybe I'm harping on this a little too much, but understanding this distinction is really key to understanding more of the complexities when people talk about, for example, a server. A SQL server is more or less a computational device, right? This kind of tool that does a lot of math, but it's built and put in a machine far, far away from you and over in OIT's server farm or whatever, and you are just accessing it and having it do some math for you and then giving you the answer, right? So a server is a computer separated from a screen and keyboard, and you can access it using your screen and keyboard, but the computer, that server itself can be accessed by many, many people, and that's what gives it that power, right? Similarly, if you want to think about cloud computing is the same kind of idea. There are a lot of computational devices that Google owns, and you rent them out on like a per microsecond basis in order to have them do computational tasks for you. And obviously you give them inputs and you get outputs, but the actual thing that Google is owning is just the computational device and the infrastructure. Press forward here. Let's talk about SQL now. So SQL works with relational databases, and more on those in a second. Initially, the relational database model was developed by a gentleman named Edgar Codd in 1969, and SQL was later developed as a language for working with these relational databases. Yeah, Edgar Codd now is sort of in Computing Hall of Fame, very, very fancy guy. And then in the 1970s, SQL itself was written at IBM, where a lot of things seem to have happened, by Donald Chamberlain and Raymond Boyce. They first wrote something called Square, but Square was not good enough, had some complexities that made it adoption limited. And so they created another version, and they called it SQL. Initially, they had an E and a UE here for literally SQL. And then because it was the sequel to Square, they later on, I think there was like a copyright thing that said they can't do that, so they abbreviated it to SQL. And then from what I understand, the actual acronym Structured Query Language was later added to make it make sense. So that's a little bit of the fun facts on the history. SQL at this stage, probably the most commonly used database management programming language. More or less every application you're using uses SQL to some extent. But because SQL is so widely used, just like English is spoken in so many countries, but it's spoken slightly different in all those places. Each place has its own regional dialect of English. Similarly, there are dialects of SQL, right? So you will have Microsoft SQL, which you use to interact with Microsoft SQL servers. The essential structure is the same, right? It uses generally the same syntax, but you do have to be aware of, okay, this one is case sensitive, that one's not case sensitive, this one's wants double quotes versus single quotes to indicate a string, things like that. Because we're going to be using the Lakehouse, our dialect will be Cloud SQL, at least in the actual examples I provide here. But like I said, this is really just a dialectical difference. Just like you can understand an English speaker from England, you can understand my Cloud SQL if you understand Microsoft SQL. So this should be more or less the same. And obviously all the underlying patterns and processes and lessons are translatable easily. Cool. Any questions about SQL, dialects, so forth? All right, so let's talk about relational databases. So a relational database is a very fancy word for a spreadsheet, basically. So a spreadsheet captures relationships between items. If you look at this super basic spreadsheet, you see one column called name, another column called birth date, and then this row represents a relationship between this name and that birth date, right? A relational database just is a database that has all these different spreadsheets. They call them tables, of course, and all of those contain the data in this structure, right? Okay, it might seem transparent that this is the right way to store data, but it is not obvious. At least it was not obvious in 1968 before Mr. Codd developed this. There are a lot of other ways to contain data that might have seemed better, right? So there are just pairwise relationships, like things like JSON uses hierarchical pairwise relationships that are a lot harder to query sometimes, but have the same, also are aimed at the same goal of capturing data. So while this structure is ubiquitous, it does have certain restrictions, right? It does not have hierarchy built into it, right? So if I wanted to do my name, my birth date, and then over here, all my friends, well, now you have to ask yourself, okay, do I have to have a different column for all my friends? Do I want to put all my friends in a single cell and make a big list of them? How do I want to handle that? And SQL often handles that by creating another table, but we can get into that later. But the idea is the tabular structure is what people are talking about when they meant a relational database, but it's by no means the only way you could ever store data, and it's good to be aware of like pros and cons on that. So with that in mind, let's talk a bit about how you could get access to SQL at CDPHE, and then I'll give you a bit of a guide on what it looks like when you log in. So in order to get SQL, you're going to need two things. First off, you're going to need access to some kind of relational database. Any relational database will do. There are so many of them around, but you'll need access to one. Access requests can be put in through OIT, and you can just get that approved. You probably need to have a real reason to get access to a relational database and not just for fun. So talk to your colleagues about what makes sense for you to have if you don't have one already. And like I said at the beginning of the call, if you want access to just a playground, you should just message me and we'll get you set up in the lake house, and you can have a toy environment to practice in. Now, in order to get access to an IDE, as you can see, is Integrated Development Environment. It's just a fancy word for the interface in which you will actually write your SQL code. Most SQL IDEs have very similar structure. There are probably two main options for you. The Lakehouse has its own. That's part of Google BigQuery's setup. So I'll give you a guide on that here in a second. But the other option would be likely SSMS, also known as SQL Server Management Studio. It's a free download, though you will have to go through OIT. So they will just put in a ticket and say, please can I have this? And you should have it pretty soon. SSMS, you write your login, you'll query something. You'll have to authenticate to a database, and then you can start running queries against it. Cool. So let's talk about what does the actual IDE look like. So if you want, we can see one here. So this is the Google Cloud IDE, but if you were to look in at SSMS, in fact, I can pull that one up if you like, it will look very similar as well. So let's kind of just do a quick tour of how this ends up looking. On the left-hand side, you have a variety of different sort of what in a general sense you might call database objects, right? So there's the highest level of these is called the server. That's like I was indicating earlier. It's just the computational device allocated to running computation on all these different databases that you have access to, right? And so just like you can see it here, you can also see it here. This is SSMS. This here is the server, right? And then you can expand the databases, and now you have a list of different databases. The database itself is essentially a collection of, yeah, sure. The database is a collection of tables and the contents therein. I don't think SSMS lets me zoom in very well. Let's try it though. No. Sorry, I think we'll have to live with a little less elegance here in SSMS, that you can kind of see the server there. So here, again, we have these. Yes, Morgan, that's a great question. Epitrax has a relational database. And in fact, you can see it here. It's got a bunch of tables, right? Any database made of tables is a relational one. Okay, so we've got our server. If you expand the server, BigQuery has a couple things like saved queries and so forth you can also use, but all these down here are essentially separate databases, which represent collections of tables that are grouped together for specific use cases. So, and you see the same here, right? So I've got like CDARS, a lot of different versions of CDARS and so forth. If you have SSMS, you probably have different ones, but that's okay. And then if you expand any given database, you will see a bunch of different tables. So I've got one here. I just made my SQL Study Hall database, and I've got my one table called COVID data. I just pulled this in from somewhere online. And over here, you can expand the same. So this is CDARS UAT. If you expand the tables, you'll see there's a bunch of them here. Their names are not particularly important, but you get the main idea. There's just a bunch of them. Now, what you want to do next is take a look at, if you click on the table, you'll see I popped open a tab that describes the table itself, and then I can start writing a query against the table. Over in SSMS, quite similar, analogous. You just pick your favorite table. Actually, I should probably not do this one because there's real data in there. Let's just do something slightly bogus. Okay, this is just menu items. So you can, there's a slight difference here, right? BigQuery directed me straight to the schema, right, which is just the list of the columns and some metadata about them. Here I have to expand the list of columns, but it's the same thing. And I can open the query editor by just right-clicking and choosing, select top 1000 or something along those lines. Okay, that should be fine. All right. So here, back in BigQuery, you can see the table, and then you can write a query against it. And then most query editors look similar. You have your actual query itself, which we don't have to talk about the syntax and everything here today. We can do that next time. But the query specifies what data you want to pull. If you run the query, you will see the results, typically displayed below in the tabular format that is typical of a relational database, right? So here you just see some very general COVID data. It looks like over in the UK on 2022, the 31st of January, there were 2 confirmed cases of COVID. So, and then if you look again in SSMS, it's quite similar. We ran our query and we got our table full of, I guess this menu text was called profile, and that was the link to it. It's not meaningful data, but you get the idea. Yeah, so those are kind of the 3 main elements of the IDE. On the left, you're navigating the database objects, key ones being the server, where the computation happens, the database, which houses the tables, and then the tables themselves. And so that's where you navigate the database objects. Then you have what's called the query editor, where you can write your query itself. This is basically just like Notepad. Just write whatever you want in here, Doesn't have to make sense to SQL or be real code. If you put not real code, the system will get mad at you when you try to run it. So you press run and it'll say, that's not a real thing. Wait, what? I guess I wrote really good code there on accident. Okay, cool. And then down here is the query results, which is just the output of your query after you ran it. If you want to see the same setup here in SSMS, which I know a lot of people use with OIT tools, you will see over here on the left is where you can navigate your objects, right? It's Object Explorer, pretty straightforward. No, you're right. I did, Blake. Trying to make an error, and I erred at making that. Then here is your query editor. And then over here is the results of your query. If you want to see where to run the query, right, that's up here where it says execute. And then, of course, there's all kinds of more interesting things you can do, like save the results and schedule tasks and whatever else, but we'll save those for another day. Okay, I think that more or less brings us to the end. Let me just finish by sharing some last resources. So in order to create a long-term resource for this, I wanted to have this sort of centralize all the documents that we create. So we've got this SQL Study Hall toolkit modeled over our predecessors, and I will obviously quite small so far, but you'll see all the recordings and and the slide decks here, and you can kind of link out to them. You should have access to this document. If you get some kind of access tonight, just let me know, and we'll sort that out for you. There's also the Study Hall interest form, which if you want to share with everyone else who may not have made it today, please let us know, and I'm happy to get them on here. You can also just invite them to the call. I added a link for BigQuery documentation in case you want to peruse that. If you need access to the Lakehouse because you want to get that SQL playground I was describing, feel free, just let me know. And we've also got, just put a link to W3. This is a good website for just talking about SQL stuff. Good. Well, I'll wrap it up there. Any last questions or thoughts? Okay, next time we'll get into some actual queries and syntax and get going. Thank you.
Thank you, Krish.